Okay, that completes the first half of the build. Let's move on to the second half. I ended up using Kapton tape, high temp Kapton tape, for the center right here. It looks nice. Okay, so our remaining steps can be performed on our workbench. Now we can install the battery terminals. You're going to need this big bag of hardware, and you're going to need the faceplate. Specifically, you'll need bag number 3. Okay, so we have our tool, we have our positive terminals, our negative terminals, the fuse holder. We have screw M614, 2 pieces plus 1 piece. And bag 27, screw M4 times 12, 16 pieces plus 2 pieces. For the battery terminals, all you're going to need is the terminals and these screws here. So we're going to set the fuse aside, set these screws aside, and this is what you're going to need. The 2 orange terminals are the positive. They'll go in just like this. You want to make sure when you put them in, they're going to be like this. Not like this, but like this. They're going to be parallel on the horizontal plane. So, like that. Each terminal will take 4 screws. Okay, when you're done, you're going to have 2 extra screws. Okay, next we can install the fuse holder. With the terminals facing upwards towards the top here, you can put the fuse holder on just like this. And you're going to use this bag of M6 times 14, 2 pieces plus 1. You'll have an extra screw. Set it aside. Okay. The Seplos 200 amp BMS. This is the version 2 of the Seplos BMS, noted by the 10E in the model number. This BMS comes with Bluetooth and a 150 milliamp passive balancer, rather small for large capacity cells. Note that the charge and discharge MOSFETs work on the positive side of the battery. This is unusual. Okay, here we have our BMS. The display, the harness, and some hardware. You're also going to need bag number 4. You'll need this bridge. You'll need the M3 times 6, 10 pieces plus 2 pieces, bag 28, bag 20, screw M8 times 16, 7 pieces plus 1. And you'll need some thermal adhesive. Okay, now we're going to take the bridge and install it across the positive terminals, just like this. In the previous video I had to take it down because I had it installed like this. This is incorrect. It has to go this way. So this is towards the fuse holder, just like this. So when you put the bus bar DK1 on the bridge, the surface of the metal of the bus bar has to go in direct contact with the bridge, just like this. Before I had it like this. So all the current would have to flow through the bolt and through this gap, so not good. So definitely make sure have the bus bar connected directly in contact with the bridge, just like this. So again, we're going to use the M8 bolts. I don't know how I missed that. That's just, I'm always a stickler for making sure that the bus bars are in direct contact with the fuse and whatnot. It's like the same idea, right? I don't know. I don't know what happened. But one of my viewers pointed it out, and I'm thankful for that. So we can correct it so that everyone can benefit. Find these little yellow button covers in one of the remaining bags. The instructions will tell you to put these on in the very last step, after the faceplate is installed, and they did not fit into the holes. It would be wise to install them at this point while installing the display to ensure proper fitment. Next, we're going to install the display. We're going to have these mounting hardware and the display. Very nice. Cool. Now it is time to mount the BMS. There are 6 mount holes, and they will go on these standoffs. These LEDs will go inside these holes. Okay, next we can apply our thermal pad. This will go right on top of the heatsink of the BMS. And this will help to transfer the heat that the BMS creates into the chassis of the box to reduce the heat buildup inside the BMS. It's like a wet noodle. Just put it on there just like a nice piece of pasta. Not really. Gonna have to eyeball it, I guess. You can see inside there, it should look like that. Nice and flush with the top of the heatsink. If you look at the bottom, you can actually see it too. You should be nice and flush with the bottom of the heatsink. On the right side. It's pretty good. Not too bad. My wife decided to help mount the BMS. Look at those nails! She still managed to get it done. With the BMS installed, it'll look like this. All your ports will be down here. Very nice. Next, we can install the battery linkages. For that, you'll need bag number 5. Each linkage will have a number on them, DK4, DK5, DK1, and so on. Remember, bag 5 will also have the fuse. 400 amps? Yeah, 400 amp, 80 volts. These are crazy looking bus bar connectors. I'm not sure how I feel about these. I think I would prefer just regular, battery cables, because I don't like these tight bends like this. I just wonder how these bends will perform under high current, if these will create heat. It's just folded over, basically. It's not even welded right there. They really should weld that and make it one solid piece. But it's pretty thick though. If you've gotten this far, take a break and go get some boba. Okay, next we're going to install the DK1 jumper. It's going to go from here on the fuse over to our bridge, just like this. And again, we're going to use an M8 bolt. All right. Perfect. Now the jumper is in direct contact with the bridge. That's how it should be. We're going to use the DK2 connector, and this goes from our power positive on the BMS over to the fuse. So leave one washer on, place that, just like that. Washer, lock washer, and nut. In the BMS box, you'll have this little bag of screws. There'll be 6 screws. These are for these holes here, 3 on top, and these 3 on the bottom. It's actually quite fun building this. Step by step, it's not that hard. Okay. Just like that. Next, we can install the 400 amp 80 volt fuse. Be sure that the fuse is in direct contact with the bus bars. There should be nothing in between. And put the washer down, and put the lock washer down, and then the nut. Make sure you get it good and tight, like the Germans would say. I should probably be using a shallow socket. Beautiful. Next we're going to install the negative side, so our negative terminals over to the shunt. This is the shunt right here. This guy right here is the shunt. And it's going to install on this side. So you're going to take off the pre-installed screw from the shunt. This is kind of funny actually. So on the shunt side they use this tiny little screw, right? It's like an M6 or something. But then on the terminals, you're going to use these huge M8s, right? It's like, wait a minute, that doesn't make sense. I mean, it's not the fault of the battery box kit. It's the fault of the Seplos making this BMS. So this is great hardware right here, but look at this little. I mean, this should handle 200 amps, but come on, man, that's ridiculous. That should be bigger. Once it's installed, it'll look like that. That's your negative connection, P minus. See on the board there, it says battery minus. I don't know if you can see that right there, B minus. Okay, next we're going to use the DK4 connector, and it's going to go from the B minus side of the shunt, the other side of the shunt, and it's just going to basically hang out in space right here, because this will end up connecting to the battery pack. Okay. Alright, so the final connection is going to be DK5. This is the main battery positive. It'll go from the main battery positive terminals on the BMS, B+, and it'll just hang out in the air because these will connect to the main battery positive of your battery pack. I think these are M6 screws. Okay, all the connections are complete. When it's done, it should look just like this. Okay, so first little snag here. This fuse holder is just a generic fuse holder, so good luck trying to put the cover back on. This cover is made for battery cables, not necessarily bus bars, so this is not going to go back on. So just put that aside because you're not going to need it. Okay, next we can install the wiring harness for the BMS and the display. In the bag there will be 3 cables. These 2 larger cables will be for the BMS balance leads, and this cable is for the display. So the display, we're going to connect the cable from this port here over to this port here next to the shunt. Very easy, doesn't need a lot of pressure to push it in. Next, we'll install the BMS balanced lead cables. It's very important that you get these in the right order. A couple obvious ways you'll be able to tell is this black connector. We'll go with the black connector on the BMS, right here. And there's a short cable, and there's a long cable. That will matter when we go to connect it up to the battery. It doesn't look like the clip is grabbing. Yeah, that clip isn't quite grabbing. On the cables, one side has a clip and one side does not. This side goes to the battery, this side goes to the BMS. Let's see if this one goes in any easier. Oh, there it goes. That one snapped in. Just press right in the middle. There it goes. These tabs should be nice and flush. Just like that. Okay, this completes the BMS install. Now we can take the faceplate and go install it on our battery. Alright, well this thing is coming together. I really like it so far. So this is probably the most critical point of building this entire battery. So please listen carefully when connecting the BMS to the battery. It has to be done in the proper order. So this is the front of the battery, and our main positive is on the right side, and our main negative is on the left side. Please verify that. You should have PCB DKA on the left side next to the main negative, and DKB should be on the right side next to the main positive. So the first step we're going to do is to connect the BMS mains to the main positive and main negative. Currently there is no voltage on our positive and negative because I have the bridge connector on the back disconnected. So right now we have two separate 24 volt packs. The second step is we'll come to the back of the battery and connect up our main bridge bus bar. That'll connect the two 24 volt packs into a single 48 volt pack. At that point, the mains at the front of the battery, the main positive and main negative, will be energized. That's why I chose to do this first and then connect it over there second. So when you're connecting the mains, you're not working around live energy. The third and final step will be connecting the ribbon cables from the BMS board to our PCB boards. The short cable will go over here and the longer cable will go over here. The longer cable will go on the DKB board on the right, and one thing you'll notice is there's a red wire only on this cable. So that means it goes to the main positive on the right side of the battery bank. On the short cable there is no red wire. We're going to need these screws, 26 pieces plus 2, M4 times 8, bag 26. This bag will be inside bag number 6. When I was putting the screws on, I had gotten the main terminal connectors gotten down here, and when I closed it, they were jammed in there and I couldn't get them up. So when you put it together, make sure these come above the cells. But be careful not to short these two, right? Because then you'll create a short, which is the reason why I have the bus bar in the back disconnected. So if you did touch these with no voltage obviously right here, there would not be a short. But if you had that bus bar connected in the back, this would be live, and if you shorted these two, it would not be nice. There's a hole right here. I'm not sure what that is quite yet. I'll have to check. That's the reset button, but there's a blank hole right here. Oh, this is the ground, obviously. And it's just, yeah, this is where your ground wire would go, right here. So 10 screws, 4 on the top, 4 on the bottom, and 2 on either side. Okay, so the remaining screws you will use for the top cover. Okay, at this point, you should have your harnesses over here off to the side, and we can continue to connect up our mains. Remember, at this point, you should not have any voltage at the main positive and main negative. Just to verify that, 0 volts. We'll connect up our main positive. That's why you put tape down here. You will lose hardware down in these holes. Now we can connect up our main negative. Now remember, this wire will be red, and this irritates me so much. I really want to like paint this wire or something. If you didn't catch it before in the video earlier, remember to check with your cell manufacturer and the type of studs that you have for the correct torque settings. Great. Moving to the back of the battery, we can install the final connecting bus bar. That'll connect our two 24 volt packs into one big 48 volt pack, completing the battery. I'm a bit nervous. So, is it going to blow up? Nothing happened. Okay, so we're back at the front of the battery. What we want to do now, with our harness disconnected, we want to check that we have at least 48 volts on our main battery terminals. And there it is, 52 volts. Excellent. Alright guys, this is the big moment, connecting up the BMS harness to the PCB boards. So, it is absolutely crucial that you do the short one first. Okay, the short one is the short one. It's the one that does not have this red wire here, see? Make sure you got that right. So this is basically cell number 1, and this is cell number 8. So this is 1 to 8. So that would be, on these wires, you'd be, well, I don't know exactly what. Usually it's these white wires that are the cells, but it would be down the line. Like, I have to look at the, I'll post a picture. But it's going to go just like that. So I'll connect this first. Okay, this right through here. It's a pretty tight fit actually. Okay. And nothing happened. Now we can install the display cover. Stuff like that drives me crazy, because now you gotta, it's a big ordeal just to get these buttons on. So to turn on the battery, all you gotta do is press the reset button. Go figure, right? Hey, check it out. Alright, so let's see what we can see on the BMS. So we got pack voltage 52.59 volts, good. 0 amps obviously flowing. State of charge is right about 50% and no warning. Let's go to cell voltage. So this shows all our cell voltages. So we've got 1 to 4 and it's in millivolts, so there's no decimal. So 33.28 volts. And it just shows 4 cells at a time, so you have to scroll down. But our cell voltages are looking good. Go down to warning. No warnings. Go down to capacity. Look at it, it's already got our capacity set 280. That's correct. It looks good. Okay, things I like about the battery build so far. The build quality of the box is actually quite nice. You can see when the cells are in the box, they weigh over 200 pounds, yet there's no sagging in the box. In fact, I've seen as much as 4 to 5 batteries stacked on top of each other. So the documentation was actually quite good. Nice pictures. I think some verbiage to go with those pictures would definitely help, especially parts like putting the PCBs into the correct sides of the battery, and also which orientation the cells can go. I think those critical parts need to be spelled out in words rather than just pictures alone. And the bit about the buttons, installing the display buttons, way on the very end, on page 50, at the very end, after you put everything together, if the buttons don't fit, you got to take the whole thing apart again. So remember to do that during the install of the display. I actually told them about this and they said they would fix it, so if they're going to do it or not, I don't know. So the things I do not like about the battery case, the power button. It is not clearly labeled, and there's not a dedicated power button to turn the battery on and off. You have to use the reset button that's on the BMS. So I think it's standard issue that a battery case should have a clearly labeled dedicated power button. The PCB on the BMS actually has a power button connector, so it's like, why can't you have a $2 power button on front of the case? I don't get it. The second thing is there's no DC rated breaker. There should be a way to isolate the battery from the pack if you have multiple batteries in a pack. Okay, so the other thing is the battery cables and the battery terminals. They are non-standard battery cables and terminals. So if you're trying to connect a battery charger or you're trying to connect a power supply to the battery to do testing, it just makes it difficult because you can't access the battery terminals. So all the issues I mentioned, the power button, the lack of a breaker, the use of non-standard battery terminals and cables, they have told me they have resolved on the newer box, so you can get all these options on the newer box. So finally, the BMS, that is yet to be determined. So after building this first battery, I think the most important thing when building one of these batteries is choosing the BMS and understanding what kind of balancer it has, whether it's passive or active, and how strong it is. But we'll talk about this more in the next video. Alright, well that's it for the battery build video. In the next video, we'll be doing the configuration and hooking it up to the system. See you on the next one.